Oh, sorry guys. I just feel like every time I put this mask on, I feel like maybe like Darth Vader or Shredder from Teenage Mutant Ninja Turtles. I don't even know if you guys know who that is. Okay, those are like cartoons from when I was like a kid. Anyways, hey, let's get into it. Gonna take this thing off. Hey, and we're gonna take a look at section 2.9 right now. And the good news about this section is that there's really no new concepts. Okay, we talked originally about if lines are parallel, then corresponding angles are congruent. If lines are parallel, and we listed off the relationships with alternate interior angles, consecutive interior angles, alternate exterior angles. Well, guess what? Their converses are also true. Now remember, what is a converse? A converse is when we flip those, right? We flip them. Okay, so now if you want to take a look down at the paper down here, here's what we have. The converse of the corresponding angles postulate says, hey, if the corresponding angles are congruent, then guess what? The lines are going to be parallel as well. Same thing with the alternate exterior angles. We have if the alternate exterior angles are congruent, then the lines are parallel. If the consecutive interior angles are supplementary, I'm going to go ahead and highlight that, say, don't forget that, okay? Then lines are parallel. If alternate interior angles are congruent, or the lines are parallel, and then it just adds on this last one. So this last one is actually the only new concept that we're going to be looking at. It says, if two lines are perpendicular to the same line. If I go ahead and draw this picture out, if I have two lines that are perpendicular to the same line, then the lines have to be parallel. Now again, why is that? We can say because the consecutive interior angles are supplementary. I could also put the right angle symbol over here and say, hey, the alternate interior angles are congruent. Or I could put the right angle symbol up here and say, hey, the corresponding angles are congruent. All those work, but again, it's another situation in which the lines have to be parallel, okay? So what I'm going to do is I'm going to come down here and I'm going to walk you through how to identify what type of lines are parallel, or which lines are parallel, okay? Now, the other day we talked about the need for a transversal within all of these type of angles, right? Okay. So as we look at this picture down here, I'm going to go down to this picture here. As we look at this picture, what I want you to know is you have to find the transversal and the other two angles that make up, the other two lines that make up that angle. Okay. That is half the battle. Once you've got that information, then you can start to ask your questions. Hey, do they meet the requirements I need? And if so, then which lines are parallel? So hopefully this makes sense as we get into this. So taking a look here, I've got angles 1 and 4. As I look at angles 1 and 4, these two angles here, what I'm going to do is I'm going to redraw the two lines that make up both these angles. So I can see that both angles lie on line K. So I'm going to go ahead and draw that up here. Okay, this is line K. And then the other line that makes up angle 1 would be line L. And the other line that makes up angle 4 is line T. And so here's angle 1 and angle 4. Now, this is so much cleaner than this down here. There's a lot less to focus on. What I'm seeing right now is if these angles are equal, they're congruent. And what that means is that my corresponding angles are congruent. So again, the converse of the corresponding angles postulate says if corresponding angles are congruent, then lines are parallel, that first one up there. So I'm going to put this down. For number 1, I'm going to put converse of corresponding angles postulate. Okay? And then I'm going to go ahead and say this. Let's see here, the directions, certain conditions, lines are parallel. Okay, so I'm just going to go ahead and say line L is parallel to line T. So I hope that it makes sense. The transversal obviously intersects both of them, but L and T will be the ones that will have to be parallel based off this postulate right here, okay? The next one, angles 6 and 4, okay? Again, I'm going to redraw the information here. Now, what I'm looking at is that angle, or line T, is shared between those two angles, okay? So I'm going to go ahead and draw that in, line T. And then I'm going to draw the other line that makes up angle 6, which is line J. And then line K. Now, what I'm looking at here is this. These angles are alternate interior angles. And according to the second statement up there, or I'm sorry, the fourth statement, it says this: if the alternate interior angles are congruent, then lines are parallel. So I'm going to put down the converse of alternate interior angles theorem. Okay, the converse of that, which we have already read it. Okay, and so if T is my transversal, the two lines that are going to be parallel is this: line J is parallel to line K. Okay, those two are parallel. Okay, so again, hopefully that makes sense there. Now the next one is written a little bit awkwardly, but here's what it means. If we add up these two angles here, that'll equal this angle here, angle 5. So again, between these two angles, the line that's shared with angle 5 is line K. So I'll go ahead and draw that out here. Here's line K. And the other line that makes up angle 5 is T. So I'll put this down, T. And the other line that makes up angles 2 plus 3 would be line L. Hopefully that made sense there. So again, this is angle 2 plus 3, and then this is 5. Okay. Now from there, we're saying that they're equal. So this angle equals this one. Okay. So again, I asked myself, what type of angles are those? Those are corresponding angles. So if the corresponding angles are congruent, then lines are parallel. So I'm going to use, again, the converse of the corresponding angles postulate. Okay? And I'm also going to say, since K is a transversal, line L is parallel to line T. Okay? All right, now, the next one says, if we add these two angles together and add in this angle, equals 180 degrees. So, again, if I draw my picture here, L is shared between the two angles here and then angle 8. So I'm going to put down that this is line L. The other line that makes up 8 is J. And the other line that makes up angles 2 and 3 is K. Okay. Now these two angles are adding up to 180. Well, if you look, these are what we call consecutive interior angles, or I could call them same side interior angles. I'm going to go down just a little bit more so we can see that just a little bit better. Okay. There we go. That looks better. So if they're consecutive interior angles and they're supplementary, I'm going to say something like this: the converse of the consecutive interior angles theorem. Okay. And then L is the transversal, so J and K have to be parallel. So line J is parallel to line K. Okay, so again, hopefully that's making sense. If we look at 6 and 8, these are going to start to become redundant here. Angles 6 and 8 are congruent, so I'm going to go ahead and mark out that line J is the line that's shared. L is coming down from that to make up angle 8. T is coming down from that, and so that makes up angle 6. Okay. So as I look at 8 and 6, lower right-hand corner, those are corresponding angles. And back up there, I mean, we've done this one a couple times now. If corresponding angles are congruent, then lines are parallel. Okay. So from there, let's see here. J is the transversal, so L and T. line L is parallel to line T. Okay. 7 and 1. All right, now, if I draw the two lines that make up 7 and 1, they share two lines, actually. They share L, and they share K. Doesn't look good for parallel lines, does it? Because the two lines that they influence, they intersect. So these are actually vertical angles. Vertical angles are always congruent. And so this is a, you can put no or no conclusion, because there may be parallel lines, but we can't prove them with this information. Okay? And maybe I'll even add this. Vertical angles are always congruent. Okay? Always congruent. All right, to finish this up, angles 5 and 6 are supplementary. 5 and 6, okay? Now again, the line that's shared between those two angles is T. And the other line that makes up 6 is J. The other line that makes up 5 is K. Okay, now, what type of angles are these two? These are consecutive interior. So I'm going to go ahead and do something like this. Move this down just a bit. I'm going to say the converse of consecutive interior angles. Okay, and these two are supplementary, and so what do I say? J was this one. Okay, what this means is this, that line J is parallel to line K. Line J is parallel to line K. The last one, angles 2 and 3 are complementary. 2 and 3 are complementary, and angle 5 is 90. So remember, complementary means that this is 90, and that this is also 90. So I'm going to go ahead and redraw these. We did this picture earlier. The line that's shared between the two of them is K. I'm going to draw the picture a little bit more accurate here. This is going to be angle 5, and then this is angles 2 and 3. Okay, and these are both 90 degrees, so I'm going to do something like that. Okay, so you can do several different things here. You could say these are corresponding angles, so you could use the converse of the corresponding angles theorem, or postulate. Okay, you could also do the last one that you said there, if two lines are perpendicular to the same line. Okay, so I could actually write that out as well. Then they are parallel. Okay, now those two lines, this was L and this was T. So I'm going to say line L is parallel to line T. Okay, so that's my answer there for number 8. So hopefully that made sense as I worked through those, redrawing those pictures, making sure we knew the transversal, making sure that we that the statements that we were given actually agreed with the requirements up here above. Okay, so again, I know I went through that kind of quickly, but hopefully you caught on to what we were doing there. Now to finish things off, I'm going to do 2 more things. The nice thing about the back side of this worksheet is this, that we are still working on developing our equations, and if you already got this, then you are good to go. But if you did not get this, then this is just some more chances to practice. So if I go ahead and take a look at these, starting with number 1, what type of angles do we have? Well, let's look at the directions first. Find x so that the lines are parallel. Okay, so we're going to prove the lines. We're going to prove the lines to be parallel once we have x. Identify the postulate or theorem used. So what type of angles are these two? Well, these are alternate exterior. And remember, we said if alternate exterior angles are congruent, then lines are parallel from the front side. So I'm going to go ahead and mark these as being congruent, and I'm going to go ahead and do something like this. This is the converse of alternate exterior angles theorem. I'm really okay with you abbreviating if you can abbreviate correctly. So here's the equation. I'm not too concerned about solving it right now. I think you guys can do that. If I'm going to prove that L is parallel to M, I'm going to have to show that these angles, which are alternate interior angles, have to be congruent. So I'm going to use the converse of the alternate interior angles theorem. And I'm going to say that these two have to be shown congruent. Okay, they're both equal. For number 3, again, I've got alternate interior angles here. So I'm going to go ahead and say if the lines are going to be parallel, then I'm going to prove the alternate interior angles are congruent. Okay. It looks like we've got some more alternate interior angles here on number 4, some alternate exterior angles in number 5, and some corresponding angles in number 6. So again, just writing out the equations. Make sure you write down the reason to converse of the alternate interior angles theorem. Alternate exterior angles, as we talked up here. Oh, there we go, sorry. As we talked in number 1, they have to be congruent, so I'll mark them congruent. This is going to be the converse of the alternate exterior angles theorem. Okay, and then lastly, this is the converse of corresponding angles postulate. So you have 5x plus 20 is equal to 70. Okay? So again, hopefully you're getting used to setting up those equations based on the requirements that we've been talking about the last couple of days. To finish things off, we've got another proof here. I want to walk through this with you, make sure you've got this down. Okay? So let's look at this first proof. We're told that angle 1 is congruent to angle 2. Okay? And then from there, we're also told that angle 1 is congruent to angle 3. Okay? So in the second step, they use the transitive property. If A is congruent to B and B is congruent to C, then A is congruent to C. We know that all 3 of those have to be congruent. That's right. From there, if these 2 angles are congruent, it may help you to go ahead and draw these separate just to see this. This is 3, this is 2. Show them congruent. And then this is A, B, C, and D. And this basically says if the alternate interior angles are congruent, this is the converse of the alternate interior angles theorem, then the lines are parallel, which is going to be true. All right, now, moving down here to this last proof. Okay, let's see how we do here. Okay, so in this proof, here's what we know is that angles 1 and 5 are congruent. So I'm going to go ahead and mark those 2 angles congruent. And then from there, all right, so angles 1 and 5 are congruent. And we also know 15 and 5 are congruent. Okay. And we're going to prove both sets of lines to be parallel. Okay. So 15 and 5 are congruent. I'm going to mark down my given. Okay. 13 and 15, how do I know that those 2 angles are going to be congruent? What type of angles are those? Those are vertical angles. They are opposite each other. And so I'm going to mark them congruent, and I'm going to write this down, that this is the vertical angles theorem. Okay? So that's how I know that to be true. Now, if both of these angles are congruent to 15, what do we know about these angles? Well, they have to be congruent to each other. Okay? And so that is just the transitive property. If A is congruent to B and B is congruent to C, then A is congruent to C. If you put substitution down there, obviously I've told you before, that works as well. So now if 5 is congruent to 13, then we know, here's my transversal. Here's what I'm going to do for this next part. 5 is congruent to 13. You've got something that looks like this. Okay? Those two angles are congruent. All right? These are corresponding angles. And based on what we learned today, if corresponding angles are congruent, then those lines have to be parallel. So I'm going to put down the converse of the corresponding angles postulate. Okay, we're working backwards there. Now, they already put down 15 and 5. They're going to put down 1 and 5 now. Angle 1 is congruent to angle 5. Okay, so if I look at this, and I have angle 1 and 5, they share R. The other line that makes up 1 is going to be L, and for 5 is M. And so what we see here is, again, that they're congruent. And so I'm going to go ahead and put down that L is parallel to M. We've already put down R is parallel to S, one part of the proof. This is the second part. And this right here, they're just stating out the converse of the corresponding angles postulate. All right. Oh, I just wrote it down there. There you go. Okay. So I hope that makes sense to everybody. You have some practice problems I want you to do from the textbook. Again, I would like you to go ahead and draw out those pictures just to make sure that you're referencing them correctly. And like I did, you know, if you're struggling to see everything correctly, make sure you go ahead and kind of isolate that stuff. So draw the transversal, draw the two other lines. Does it meet those requirements? And then from there, hopefully you can come up with the right conclusion. Anyways, thanks for listening today. I know that was a little bit longer than I had anticipated, but have those practice problems done for me for tomorrow. Thank you, folks. Bye.